Hello, everyone. Welcome to the study season. Today's session about modeling and simulations of decentralized economic systems with AI and machine learning. We are back here in the session with Muhammad. Hello again, Muhammad, and hello, everyone. Welcome back to today's study season session. For those of you who are following us on Twitter or YouTube, you still have the chance to register via tokenengineering.net to have full access to all the information, session recordings, and you then have the chance to acquire an NFT proof of knowledge for passing an exam or for submitting a homework. So it's still, the registrations are still open. Okay, the topic today is modeling and simulating decentralized economic systems with AI and machine learning with Muhammad Idrees. It's the third session in this series of lectures, and we'll have 4 in total. Before we start this session, I just want to share again that we are giving away free EFCC tickets. You might have heard about the token engineering track at EFCC. This year, EFCC is going to take place in Brussels, and it's hard to get tickets. They are usually sold out within minutes, with the final round of ticket sales taking place in a couple of days. And TE Academy gives away 5 tickets. You can win a ticket worth 500 euro by recommending the Token Engineering Reads newsletter to your friends. Just refer them to 3 friends and have the chance to win your free ticket. I think submissions and
Angela,
subscriptions.
can you share again your slides on social media? We are muted on Facebook, well, and on Twitter.
Okay, wait.
Thank you.
Thank you. Let me just check what's going on. Let's see. It should be fine. Okay, I'll continue. All right, so this giveaway is open until Friday. And now let's just see. I'd like to give an overview on the remaining sessions for Muhammad's series. The final session after this one today will take place in 1 week on May 30th. And the topic of this final session will be emerging research topics in token engineering and AI and machine learning. And you are welcome and invited to bring your own questions when it comes to the application of AI and machine learning to token engineering. I'm sure there's a lot to discuss, and Muhammad is open to answer on your question based on his experience and his research in this area. So we'll have time to discuss your questions. And after this final session, you can take the exam to receive your NFT. And we'll share all information needed for receiving the NFT, for your submissions for the exam next week. Okay, that's it for now. Muhammad, the stage is yours. Let's kick off the session.
Right. So can you see my screen? Angela, am I audible?
Yeah,
guys?
it's all good. Perfect.
Okay, and you guys can see my screen. Slides are changing, so that's good. Okay, so hello everyone. Welcome back to our third session in this track, and today we will be diving into the domain of generative AI powered modeling and simulations with a focus on our custom tool, which is a token GPT. So in our previous sessions, we discussed the importance of modeling and simulations in decentralized economic systems and how AI and ML can address some of challenges faced in token engineering domain. So in this session, we will explore the power of generative AI, which can further enhance these processes and making them more efficient and insightful. So we will cover various aspects of token GPT, how it uses the LLM interface, and its capabilities of RAG and function calling. Let's get started with this. So these are the topics which we will cover in this session. So first of all, we will introduce Token GPT and its capabilities. Our custom AI tool, it's designed for token engineering tasks. We will discuss about the different capabilities of Token GPT, that how it can assist in designing, verification, and optimization of token economies. We will also discuss the technical architecture of Token GPT. And in this technical architecture, we will see that how different functionalities are implemented, so that anyone who want to build a similar tools for him, to a tool for himself, or even integrate his specific use cases with this Token GPT, so he gets an overview of architecture, so that he can build his own tools and use cases. We will have a demo of Token GPT application. So it is a Gradio-based application with a UI, so we can see that how it works and what are the different functionalities of it. We can test it. And I will focus on the architecture part, because I really want this tool to be used by different token engineers to integrate their own tools and integrate their own different analytical tools with this Token GPT, so that we can really use the power of LLMs and this generative AI to enhance our token engineering workflows. So before we start this session, I will give a very brief recap of our previous sessions, because I want to really build that how we reach there, why we require generative AI in our token engineering flows. So in our first two sessions, we discussed that why modeling and simulations are critical in designing token economies, and how these tools help in designing robust and sustainable systems. We discussed challenges associated with modeling and simulation tools. We explored that how these tools are complex to operate, design, and to convey the objective of these tools to stakeholders who are from non-programming background is very difficult. And we highlighted the need of tools with better user interface, so that anyone can interact with them and understand the findings from our simulations. Then we discussed how we can use AI and machine learning to address these challenges. We went through a case study of intelligent liquidity provisioning mechanism, that how we can enhance our models and simulations with the application of AI, and how we can abstract a lot of work like defining mathematical specifications and integrating data into our models by leveraging AI. So after this case study, we in this session will explore that how we can use LLMs to further enhance the different tasks which we perform in our token engineering workflows. So let's start with the understanding of Token GPT and what it brings to the table. So Token GPT is a custom chatbot which is built using ChatGPT's API. So it leverages ChatGPT's API to provide an intelligent conversational interface very similar to ChatGPT, and it can understand and respond to complex queries. Everything which you can do with ChatGPT, it can do, and plus other functionalities which we have integrated. So this also has RAG implemented in it. So RAG basically the retrieval augmented generation. In RAG, we have this knowledge base of token engineering tools, tasks, and everything. So it's not a general purpose chatbot. It is tailored for token engineering tasks only. So it uses RAG to access and utilize a knowledge base, ensuring that its responses are more accurate and contextually relevant to the token engineering tasks which we are trying to perform. So its capabilities include function calling for different type of tasks like data extraction from APIs of Subgraph, Uniswap, DeFi Llama, and other tools. We can extract that data from these tools without writing any line of codes or calling any API, but just from the text-based input, and it will give us the data. Then we can analyze this, plot that, and ask questions from it based on this data. So these are the different components of this token GPT. So it has a chat GPT's API integrated. It has a knowledge base which is retrieved using RAG, and it has function calling capability. It is integrated with different data extraction tools from public and private APIs. And it also has data analysis tool like price impact analysis and different functionalities which are embedded in quantitative token model, or also part of its tool set. So it also has capability to plot graphs and visualizations, and you can see all these visualizations from your Gradio interface. And Gradio interface makes it very easy to bring it from the production, from a research environment. Instead of using it in a notebook, we can have a very real interface, like just like ChatGPT, where token engineers can interact with it and pass their queries. So let's have a look at how the token GPT will be used and what are different capabilities of it. So token GPT is designed to assist users in the domain of token engineering, and it has data-driven insights and recommendation which a normal regular chatbot cannot provide. Its a high-level goal is to help users navigate this complex decentralized economic systems world, and they can use it to design verification for the design, verification, and optimization of economies through its capabilities of tool calling and function calling. It has a very easy and user-friendly infrastructure, so anyone who wants to build on top of this tool, so he can integrate his own functions, and he can easily use it for his personal assistant based on the use case he wants to develop with it. And it has a architecture where it takes any instruction from the user step by step by planning all that function which it has to perform, and then call any specific or relevant tool related to user query. So it can select tools. It can then ask user for if it needs any parameters or any values to work with that tool. And then once all the requirements are met, then it will perform the analysis and by performing the function call. And once the function is called, it has some outputs. So it will interpret those outputs in a text-based language. Instead of giving you the tables and all the data, it will interpret that data for you. So it will also save all that data and graphs into your local storage, so you can see the CSV files and diagrams and different plots which it has built for. You can use it for anything, for presentation, or maybe if you want to go use it for further analysis. It has a capability of this intelligent orchestration where it maintains the memory states. It has a long-term memory and short-term memory, so it has all the context of your conversation, that what the user has talked about in the previous conversation, so that it can use those for his context and then perform different tasks. It's all by understanding these roles, we can see that how token GPT is designed to function effectively, providing users with the insights and tools they need to use in this token engineering domain. So this is a very high level architecture of token GPT. So there is a chat GPT API, and then we have implemented RAG with that and this function calling capability. And for the RAG, we have vector database where it stores all the data of knowledge base, and there is a vector search algorithm which retrieves all the data from the RAG from this vector database and embeds it into the user query, so that when the ChatGPT API accesses this gets this user query, it is rich with knowledge from this vector database. So we will discuss in detail that how RAG is implemented and what are the different components of RAG. And function calling, it has tools and functions which are integrated with it, and you can interact with all these capabilities from a radio interface, so you don't have to manually code anything or do anything. You can just interact from a text box and by giving your inputs. So let's see that what RAG is and how it makes our token GPT better than a custom chatbot. So RAG is a technique that combines the strengths of retrieval-based and generation-based models. So traditional language models, they generate responses based on their training data. And retrieval-based models, on the other hand, they can fetch specific information from the knowledge base. And RAG combines these approaches by retrieving relevant information and using it to generate more accurate and contextually rich responses. So it enhances the capability of token GPT in specific domains, like RAG can give you the context of the project on which you are working. So you can upload the document if you are working on a specific problem. So you can upload research papers related to it, and then you can interact with the LLM with the context of all those documents and research papers. When a user gives a query, the RAG retrieves relevant information from the knowledge base, which is dedicated for the token engineering for or this specific use case. And then retrieved information is used to generate a response, ensuring that answer is both accurate and highly relevant to the query. These are different components of RAG pipeline. So RAG has a vector database. It is the system in which it stores the embeddings of the knowledge base. So user with the knowledge base which we have integrated, it's converted in the embeddings, and these embeddings are stored in this vector database. This database enables that efficient retrieval of that information based on user queries. And the second most important component of a RAG pipeline is the knowledge base, which consists of a vast amount of domain-specific information. It could be in PDF format or doc format or in CSV format. So this vector database can handle all these data types. So you can upload documents in any of these formats to embed them in your knowledge base. Embeddings are basically the numerical representations of the data that captures semantic meaning of that data. So to give you a high-level example, that if you convert some words into embeddings, so words with a similar meaning will have very similar vectors which will be representing them. So they are multi-dimensional vectors. We cannot visualize them because they are multi-dimensional, but we can just give a preview of them by just with this very simple example, that if you create a vector of word good and excellent, so their vector representation will be very similar because they have very similar kind of meaning. So if good and excellent will have very similar kind of vector representations, and in contrast, bad will have a vector representation which will be very different from the good word. So that's how these embedding models, they convert all the data which you have uploaded for your knowledge base into these embedding vectors. And then the retrieval component is responsible to fetching the most relevant embeddings from the vector database. So it matches the user query. So whatever query user enters, it creates an embedding vector of that query too. And then it compares them with its knowledge base, and then retrieves any relevant information from the knowledge base into user query, so that if you give a very simple query to token GPT, that what is CAD, so it will search that for the word CAD and retrieve all the relevant documentation of CAD from its knowledge base. So in knowledge base, we have all the details of tools like how it works, how to set up CAD, and what is the purpose of CAD simulations. So if user gives a very simple query to chat GPT, it will not have all the context of CAD tool, so it will generate response based on its training data. In contrast, this token GPT will get all the relevant information to CAD and that embed that information into user query. So once now the user input goes to this language model, it has all the relevant information of CAD. So its responses will be more relevant to the task which you want to perform. The RAG pipeline has a vector search algorithm. The most common vector search algorithm which is used is cosine similarity. So there are multiple other algorithms which can be used for vector search. So what this algorithm does, that it tries to find the most relevant information from the knowledge base. So there are different techniques to find that what is relevant and what is not relevant. So this cosine similarity, it basically calculates the distance between the embedding of user query and embeddings of the knowledge base data in the knowledge base. So it calculates that which two vectors are most which vectors are more similar to the user query, and then it will return that information to the model. So these vector search algorithms, they are very important in retrieving relevant information. So there are multiple algorithms available, but the most commonly which is used in this industry is currently the cosine similarity algorithm. So we have implemented that. So once the relevant information is retrieved, it is used to augment the user input. The augmented input provides a richer context for generating the final response. Finally, the augmented input is passed to the generative model, which is our LLM. We are using OpenAI's ChatGPT-4. So this model will produce context-aware response. The response is informed by both the user query and the retrieved domain-specific knowledge, ensuring that it is very relevant and accurate. So user query is passed to the retriever, and retriever, in this diagram, you can see that retriever retrieves the relevant information from the knowledge base, and then it goes to the generator model where this generator model actually generates the final output. So let's discuss that how RAG works. And the process begins with the user input, which is processed to generate a query. The query is then converted into embedding that can use to search the vector database. And the next step involves retrieving relevant documents or data from the knowledge base. And the retriever component uses the query embedding to find the most relevant embedding which is stored in this vector database by employing the vector search algorithm like cosine similarity. And finally, the token GPT generates responses using this retrieved information. The user query is augmented with retrieved context to provide accurate and context-specific answers. So what are different benefits of using RAG in our workflows? That it improves the relevance and accuracy of our responses, and it also provides us with the up-to-date and context-specific information or knowledge. So RAG allows this token GPT to access most current and relevant information available in the knowledge base, which you can upgrade periodically. You can upload any document at any time, so you can update this information, which isn't possible while you are working with ChatGPT, because you cannot. Sometimes it will say that it doesn't know about this thing, so you don't have anything. You can't do anything about that. It also ensures that responses are not only accurate, but also they are contextually appropriate, reflecting the latest developments and data in the token engineering domain. So here is the diagram of implementation of RAG in Token GPT. So here we have all the documents related to token engineering domain, which includes publicly available research papers and also some of the documents which I made myself during when I was trying to learn the token engineering. So I had all the documentation and the learning path with me. So I uploaded all that stuff in this knowledge base. In these documents, converted them into these documents, and some also annotated them with properly, so that once they are stored in the vector database, so they can be retrieved easily. If they are not annotated properly and they don't have headings or topics with the proper title, so it will face difficulties while the LLM will try to retrieve these documents. So these documents are converted into the embedding. So here you can see that the very simple visualization of embeddings. They are not like this because they are multi-dimensional. They have thousands of dimensions in actual, but they are represented here in a very simple manner, that how these documents, they have different kind of meaning, and they are clustered with all the documents with similar kind of meaning are clustered here. So document 1, 2, 3, 4, 5, they are very close to each other. It means that they are trying to address one topic, and the other document 6, 7, 8, they are different. They have different representation, and they are addressing some other topic. So all the documents with similar kind of context or meaning, they are located very closely in this while they are represented in this embeddings model. So these embeddings are then stored in this vector database. So FICE is a vector database I used. So it's a open source database, anyone can use it. It's free. So there are other vector databases also available, but this is the most simplest. It is with most simplest implementation. So we use that for our model. So these all embeddings are stored in this FICE vector database. And when user queries here in the red box, user query is passed, it's converted into the embedding. So user query also uses the same embedding model to convert user query into embeddings. So there are different embedding models also available on Hugging Face. You can go to Hugging Face leaderboard and see that there are multiple embedding models which are used to convert the documents into these word embeddings. So the OpenAI's text embedding model is the more which is widely used in this industry. There are other models from Mistral and other model providers. So there are multiple models. You can use any one of them to convert your queries into these word embeddings. And these word embeddings of user query, they are also passed into this vector database. And then the search algorithm, which we discussed earlier, it is used to retrieve the relevant information from this vector database and augment it to generate a very comprehensive user query, which will be passed to the LLM. So here is another representation of this. It's very similar to what we discussed there, but it has I just picked them from Google. So it is a little bit more detailed, like you have raw data in form of documents, then you can extract the relevant information from that data, and then you make chunks of that data. That's really important because you cannot feed the complete documents to and generate their embedding. So you create chunks of data which you want to embed in this vector database, then create embeddings, store them into vector database. User inputs his query, then it's converted in the embedding model, then it goes to the vector database, and our search algorithm, it compares the user query with the data available in this vector database and returns the relevant data to the LLM, and then LLM generates its response. there's another, it's another figure here, but it's very similar to what we discussed previously. So we can just skip this. So
Muhammad,
yeah.
Quick question. Tiago
Got
dropped a question in the chat that I think is worth picking up right now. Tiago, I read it out, or would you like to switch on your mic maybe? Not sure if you can. Library, okay. Tiago asks, you mentioned a vast knowledge base on token engineering. What were some of the data sets you trained the LLM with? And maybe this is good to clarify, training LLMs versus providing memory.
So, Tiago, training, fine-tuning, and RAG, they are very different things. So while you train an LLM from scratch, that's basically that it takes a lot of computation, and it is not possible to do that because it's only possible if you have millions of resources. So we cannot certainly train a new model for token engineering tasks. So what we can do is fine tune an existing trained model on token engineering database. So fine tuning is another technique which was really good during the earlier phase of this generative AI. But the latest research has concluded that the RAG, which is basically, we are not training the weights of our LLM, their weights are the same. So the weights of this complete neural network, they don't change. We don't train them. We just have a knowledge base. So if you I just try to explain with this example that if you give a query that to ChatGPT that what is the weather in Belgium or something like that. So if you with ChatGPT, that's not a good example. Let me just rephrase this. So if you ask a question to ChatGPT, it's what is CAD? So what ChatGPT will do that it will based on its training data, it will generate a response if it has CAD's data in its training data included. So it will give you an answer. Otherwise, it will give you something rubbish and very different from what it actually is. So while you implement this knowledge base, you don't train the weights of your model. You just embed the data into this knowledge base. And when you give this query to your language model, it will retrieve all the information from the knowledge base and then embed into your input. So from your user interface, you are just giving this one line, but when this query goes to the language model, it has a lot of data with it. So it's not a simple what is CAD. You will have a lot of data included in this user input, which is basically implemented using this RAG. I hope this is clear. Even if it isn't, we will see in our demo and you can feel that how this works.
Tiago said, got it. Thank you. Perfect. One more comment or also question. You have been using OpenAI's GPTs for your experiments on Token GPT, right? But there are, and I mean, this is what what makes OpenAI so successful now, because it is hard to train an LLM. However, there are alternatives, open source alternatives, even Llama 2 or Falcon. I just wonder, have you tried them out? And in case yes, what's your experience with alternative LLMs?
So honestly speaking, they haven't reached the performance goal which OpenAI's ChatGPT has. So it is much better than every other open source LLM. I have tried Gemini, Llama, and Mistral, and all those models. We read research papers that they have enhanced their performance by that % every day, but they aren't good enough. They aren't good enough with maths. They can't think analytically. They can't respond like ChatGPT. So ChatGPT is the best model, and we are not in the AI innovation business. We are actually the token engineers, so we don't have to go a lot into the how these which model is better, what fits better to your use case. We can use that. Only problem with ChatGPT that you have to pay So that payment is very negligible because the subscription isn't that expensive. So you just pay and focus on the main task, which is the integration of token engineering tools and all that stuff.
Okay, I would love to add, okay, since we are active in open permissionless systems and working in the public good spectrum, I would love to see open source LLMs. Let's see how the space evolves in the next years.
Yeah,
Thanks
actually,
for the
that's
comment.
really interesting topic, and we will discuss BitTensor in our last session. So BitTensor is a distributed AI technology which lets users to contribute their data, to contribute their compute, and we will have distributed models which are not owned by any single entity. So that is very useful case which is built on top of blockchain, that decentralized data sets can be used to train AI models, and decentralized compute resources can be used to train those models, and the algorithms are also decentralized. So it's a very useful case if we are about the future of AI, that how the regulations and all that stuff around the monopoly of top companies in this generative AI domain, due to its requirement of very heavy resources and money. So BitTensor is a very good use case of what we are trying to achieve in this decentralized world. So we will discuss that in detail in our last session.
Cool. Thanks.
Akash network is also another. So there are multiple. I have shared the links of 16 to 18 projects in this Discord channel. So they are all working on decentralized LLMs and decentralized how AI can be democratized and we can make it permissionless. Okay, so let's go ahead.
I have a question.
Yeah.
Faisal, this side actually, in the previous slide, you were teaching that the raw data is divided into the chunks. This partition is based on the similarity of the data, or is it not the similarity? It is distributed randomly.
Yeah, it's distributed randomly. So just because if you have a large data, a document which consists of 80 or 90 pages, so when the embeddings will be created of that document, the one embedding vector will be created to summarize all the content of that document. So that document could have very diverse kind of information which is very different from each other. So if you don't chunk the data, it will convert that 80-page document into one embedding vector. But if you convert into chunks, different chunks, so different parts of data in your document which have very different kind of meaning, they all have their own embedding vectors. In that way, the retrieval will be very efficient. So if you have one embedding vector versus 80 embedding vectors for each page of that document, the retrieval algorithm will perform much better by retrieving the relevant information. Faisal, I hope that answers your question.
Thank you, Mohammed. I got it.
Okay, thank you. So next we will go into the example of RAG in token engineering. So we will take a very simple scenario that user asks a question about the token distribution strategies. So imagine you are working on designing a token economy and you need to insights in the best token distribution strategies. So this example will explain that Tiago's concerned also about what is difference between RAG and fine-tuning and retraining a model. So user wants to design a token economy and he need insights on the best token distribution strategies. So you ask TokenGPT, what are the effective strategies of token distribution in new decentralized project? So you asked a very simple question without any context of your project, what it is doing and what are the best distribution strategies. So what RAG will do, that it will bring retrieve the relevant documents and frameworks. TokenGPT will process your query and convert into an embedding. This embedding is used to search for the search in the vector database, and it will retrieve relevant documents, research papers, and frameworks related to token distribution strategies. So now once this user query is passed to the LLM, it will not have this very simple question of what are the effective strategies for token distribution in decentralized project, but it will have all the context which is returned from the vector database along with it when it's passed to the LLM. So it will have the information about all the strategies which are being currently used, what are their results, and everything which you have embedded in your database. So this all context goes with your query by making it rich with the relevant information. Based on that, Token GPT will give you a detailed response based on this retrieved information. With the retrieved information, which will be augmented in your query, it will generate a comprehensive and context-specific response. The response might include various token distribution models, case studies of successful projects, and recommendations tailored to your specific needs. And that's how RAG makes our token engineering workflows much better and different from while you are interacting with the general purpose chatbot. So the next most important feature of ChatGPT after the RAG is function or tool calling capability. So let's discuss that, how the tool calling or function calling works. So Token GPT can call external functions and tools, which is one of the capability which is offered by the ChatGPT's API. So you don't in the ChatGPT, Angela and all the team, they implemented it manually, but now OpenAI offers built-in capability, so you don't have to do a lot of work. You can just give the description of your function and parameters it needs, and they get integrated with your model. And the question which we had earlier, that why use ChatGPT with the other open source models. So other open source models don't have this capability. You have to implement function calling manually, and that is very difficult because it will take a lot of time. So with OpenAI, you don't have to do it manually. So what you can do with these functions, that it will allow you to fetch real-time data. Like you can call different APIs to get the real-time data from different data platforms, and you can run simulations by calling the functions of different simulation models which you have built in your system, and it will really increase the utility far beyond static responses. What is the purpose of function and tool calling capability? The primary purpose of this functionality is to extend Token GPT's capabilities beyond providing static answers. By integrating dynamic and interactive functionalities, Token GPT can offer more relevant and actionable insights. And let's say if you need real-time data of top performing Uniswap pools, so Token GPT can call an external API to fetch the latest data and present it to you. Similarly, for complex calculations and simulations, like if you want to perform price impact analysis or running a CAD simulation or a token SPY simulation model, so Token GPT can invoke these functions to deliver precise results, and it can also present them in a format which you want, which you can't do with the simulations. So how this function calling and tool calling capability of Token GPT works. So let's break down the workflow of how this works. And first of all, we will what Token GPT does is identifies the need. This process begins with the Token GPT identifying for external data or computation based on user's query. So for instance, if you ask the latest data on Uniswap pool, so it will require a complex calculations and API calls and everything. So Token GPT recognize that it needs to go beyond its internal knowledge in order to get that data. So it will identify the need of using an external tool. Then Token GPT will, after the identification of this tool, will see that what this tool requires in order to call it. So let's say if you want to fetch the Uniswap data from subgraph, so you need to provide that how many pools you want to get data of. So like you can get data of 10 pools or 15 pools. So it will ask you that this question that how much data do you require, and then it will convert the user's response into JSON format, and it will be passed to that function as parameters. After that it will call the appropriate functional tool, which could involve accessing an API to fetch real-time data, or running a predefined script for the analysis, or invoking a simulation tool for more complex tasks. After that, it will fetch the results. Called function or tool performs its tasks and returns its result. These results could be data points, calculated values. They could be simulated outcomes, or depending on the nature of the function called. So it can be anything like a graph or a data frame or a CSV file or one number. So it will return you the raw response, and you can interpret that with the by further querying that what this means, what this graph means, or by doing any kind of stuff with this LLM. The final step of this function calling workflow includes token GPT using the fetch result to generate a comprehensive response. This response is now enriched with real-time data, plus calculations and simulations, plus the analytical capabilities of language models. So if you are running a simulation in isolation, it will not leverage the analytical capabilities of an LLM. But now your response has all those components together: real-time data plus capability of a simulation and model, plus the analytical capability of your LLM. So it incorporates all these things. This is a simple flow of function calling. So let's start with the user prompt. User prompt goes into our application, Gradio application. So this user response will be passed, user prompt will be passed into the model which we are using. So currently we are using GPT-4. So GPT-4 will get this user prompt. It will have the function details in its context. So user prompt and function details are passed to this GPT-4 model, and based on that, it will analyze that which tool it wants to call, whether it wants to call a tool or not. All that stuff is being done here in the model, and then it selects that which tool to call and what parameters this tool needs. So it will, if the parameters are provided by a user in his initial prompt, it will just call the function. If those parameters aren't provided, so it will ask user to give these parameters in order to perform this function call. So once it has all the parameters of function call, it will call that function, maybe which is an API call or anything, running a simulation or anything like that. So this user response from the function call is again passed to this language model, and now it has user prompt plus the response of that specific function call or API with it, and then it analyzes this response of function call, and it will return you all the response, which includes now the response from the language model plus all the data from your function call. And there are these three major components of function calling capability of token GPT. So it has a function library where it has a collection of predefined functions and tools integrated into it. These functions cover a wide range of tasks, such as data extraction from Uniswap subgraphs, DeFi Llama, Dune Analytics dashboard. And it has also integrated some data analytics tool like calculating price impact analysis, Uniswap's V3 simulator, and other DeFi functionalities like helping versus borrowing returns, and these kind of analytical tools are integrated with it. token GPT uses an API to access external data sources. So this API, the public APIs can be accessed by anyone, but if you are using a private API, you have to provide the API key. So it also integrates that with the API call. If it requires in the input parameters, it will ask user to give him the API key of Dune Analytics so that it can call that specific function. Otherwise, if it is a public API, it will just access that without asking user to give it to him. And then the final component is execution in my environment. So all the functions run in a system in an execution environment. So currently I am running this token GPT locally into my laptop. So the execution environment is a Python virtual environment where all the dependencies of the tools and functions which GPT wants to call, they are installed. If you are running locally, you have to install it in your system. Otherwise, if you are using a cloud service, so you can maybe Dockerize your tools and install all dependencies in container, and anyone can use them. Okay, so here is a very simple example of function calling, which will be see in demo that how it works. So let's say you are trying to analyze that in which pool you want to provide liquidity in Uniswap. So user will ask token GPT that I have that amount of budget and I want to provide liquidity on Uniswap. So what it will do, that it will go to the subgraph API of Uniswap and will give you the data of top maybe 30-40 pools which you want to filter. So after that, you can use that data to like perform analysis that which pool has produced the most amount of fees or which pool has the greatest volume. So you can check all those things, and then at the end it will recommend you that this is the pool which, based on your preferences and all the real-time data, this is the pool where you should provide your liquidity, or this is the best which best suits your requirement. These are the future enhancements which can be done in this token GPT. We can integrate different governance, analysis, and data tools with the token GPT to increase its capability. Like we can get the data from some platforms like what we can improve voting processes, we can improve user interaction with DAO platforms, and we can improve governance data analytics capability with this token GPT by integrating all these tools of DAO management and user interaction. Maybe we can use Aragon client to get the data of DAO, and then use token GPT to analyze the data. That data could be qualitative or quantitative. So we get a user who is a participant of that DAO and doesn't have a lot of knowledge of programming to perform complex analysis based on their qualitative or quantitative data. So he can use token GPT. Token GPT will get this live data from this Aragon client, and then based on that, it will recommend any actions or provide insights into the voting process and different proposal approval or rejection process. Similarly, we can use it for snapshot, boardroom, Governor Bravo, and others different type of governance platforms. So that is a very useful, that could be a very useful tool in this domain if we leverage the capabilities of LLMs, which are very good with converting qualitative data into quantitative data, and do vice versa for the participants of the DAOs, where a lot of people are individual contributors and they don't want to do complex analysis and simulations in order to participate in the DAO. Another feature could be to integrate smart contract audit tools and frameworks like Slither with your token GPT. So you give him the contract code and it will perform that audits and all the necessary checks in order to give you an overview of your code quality or if he finds any bugs. So you can integrate a lot of smart contract audit and formal verification tools with it to automate the process of smart contract audits. And we can also improve the knowledge base of token GPT. So based on my experience and data which I had, I integrated that with this, but all other people have different kind of diverse data resources. So though this data can be improved and we can make it more rich and specific to token engineering domain. And we can also integrate smart contract development and deployment tools with this. Like we can automate the process of smart contract deployment with this token GPT, but that will be something really advanced. We need to do a lot of, because that's very critical, deploying and developing smart contracts. So we can use multiple agents, one for development of smart contract, another agent to perform its audits, and then third one to deploy these. So we can use this chain of agents with the token GPT in the middle to automate this process of smart contract development and deployment. Okay, so that's it from the presentation side, and now we will move to the demo of Token GPT, and I will share my screen with you guys of the Gradio interface which we have here. Okay.
Just as a reminder, everyone, in case you have any questions, just drop a note in the chat or feel free to switch on your mic anytime.
Let me just go to this new interface. Okay. So can you guys see the screen here?
Yeah, we now see the chatbot interface.
Okay, so let's start talking. Okay, so yeah, as an AI assistant focused on token engineering tasks, I'm equipped to offer specialized support in the realm of decentralized. So these are all the capabilities of token GPT, and we can ask to perform any one of these tasks. So what can you do for me to build a token to help me in token engineering tasks? Okay, so it said that it can get Uniswap pool data, perform price impact analysis, get Uniswap data from the Dune Analytics. It can do price modeling, strategy planning, data retrieval, and analysis. So let's start with the Uniswap pool data. top Uniswap, it can give me top Uniswap pools that are daily historical data, and it can use it to give me historical prices and everything. Okay, I need top Uniswap pools. Sure, how many top Uniswap pools would you like to get data for? 5. So that's where the first function is called to get the Uniswap data from the Uniswap v3 pool subgraph API. So the function calling takes a little bit time, so it will take maybe 30 to 40 seconds to process this. I will show you the code and my virtual environment where I'm doing this, where when you see that all the data which it is bringing and all the stuff. So it has returned me the ID, liquidity, fee tier, and a lot of data. And this data is also saved in the CSV format in a LLM data directory, which is in my project. So this data is saved there, and it also displays you with the graph, and you can ask his question that which pool has generated maximum fee. Okay, it gave me the ID of this pool which has made just maximum fees. So now I will ask you to give me the daily data of this pool. Okay, number of days for which you want to data. So I will get the data of 10 days. It again, that function call is being done, the API is being called, and I can see that in my terminal that it has called the API of Uniswap v3, got all the data, and we can see the response here shortly. Maybe let me just share my complete window with you guys so that you can see what's happening at the back end, which functions are being called. And
the query to ask. Am
sorry?
I audible? Am I audible?
You are audible.
Actually, you have taught earlier that now the function is called of the pool data, but the parameters are not defined. So it asks as a question in the form of query, and you have defined that function parameters.
Yeah. When I asked it to give me the daily data of the pool, so it knows that with pool ID it is calling, so it requires additional information like how many days the data it will require. So it asked me if it will have any other kind, this function has any other parameters, so it will ask me to specify those parameters before calling that function. Like here it said that specify the number of days for which you want daily data for. So this is a parameter of the function. So now it has given me the data of this Uniswap pool of 10 previous days. So it has also plotted all the results of historical data of 20 days. Like it has this price plotted, fees USD, liquidity. Here is liquidity and square root price over time, fees over time. And these all plots are made by the function which I have integrated in the backend, and there is this data you can see in the top table format, and also the same data is saved in a CSV format in this folder. So you can see this data in the CSV format. You can see here in the table, you can ask more things about like which day had the maximum volume, at which day the price was maximum, or when liquidity, how liquidity increase or decrease. So it can answer all those queries based on this data. So if you are using ChatGPT to ask very similar kind of question, it don't have access to Uniswap subgraph API, so it will give you rubbish and random answers. But with this, it will give you the exact answer, like on which day, how much volume was generated, what was the exact number. So you don't have to rely on the abstract information. You can get the exact information for that. Okay, so next other function which I have included with it. So let me ask it that can you do price impact analysis of different token sinks for native token of my project. Okay, so yes, to perform a price impact analysis, different token six of the native token of your project, I need the following data. So it requires these data points in order to perform price impact analysis. So these are the parameters of this function. So it asking for initial weekly transaction volume. So I will give it a random number that initial weekly transactions are initial weekly transactions are 1000, and we have circulating supply of 1000K, and we have initial price of 0.56 USD. 100K circulating supply, and price is this. Okay, so now it will call the price impact analysis tool which is integrated with it. So it will perform the analysis of different token sinks on the price of a token based on these initial parameters. So this tool has a lot of other parameters which I have set by default, but because I wanted to make it easy for demo, because of providing all those parameters in this query will take a lot of time, but you can get all those parameters from the user, like how much the growth rate has been observed in the previous days. So it can get all those parameters from user, based on that perform price impact analysis. It will plot the graphs for us, give us the detailed table of all the prices at different points of time, and give us its analysis on that, what will be the price of token in few days, everything. It's taking a lot of time because the function is being called and it has to do all the stuff. Let me just share my other screen, which is the code where everything is running. So there in terminal, you can see calling the APIs and getting all the data, plotting all the results and everything. So this is the result it has produced. So based on these initial parameters, we have the plots of effective circulating supply over time, like it will decrease, it is decreasing, and token price over time is increasing initially and then getting stable, then different demand over time, and how many tokens are locked in different utilities over time. So it has plotted all those results. It also gave me all the data of transactions, initial transaction week one, then how they are growing based on the model which I used in my function. So tokens locked over time, token release, weekly supercharge, and everything from price to. So it has given me this detailed table. It has also generated a CSV file in my directory for if I want to upload it again and do anything else, or maybe use it for some other stuff. So it has all those things integrated with it. So you can do a lot of other things. There are a lot of tools to be called which are already integrated, and you can also integrate your personal tool with it. So I will give access to participants who are interested to set up this up in your environment. So you don't have to do anything. Just clone this repo, which I will share with you guys, and then with a simple command you will get this Gradio interface, and then you can interact with this token GPT, perform different kind of function, anything which you want to do within the capabilities of this, like the tools integrated with it, and you can integrate others tool also. Now I will start sharing my other screen where everything is happening. So let me
And
know
we
if
have, I just want to mention, we have another question in the chat that you might be able to pick up right away. Tiago asks if the GPT, token GPT, can read data sets. So can I not only download, but also upload CSV files? I guess this is the question.
Actually, it can read images. So here, if you can see here, it can get lets you to upload the images right now. It can't really get the CSV file, but that isn't very difficult. I will integrate it in a couple of days. I was just wanted to keep the demo as simple so that it just doesn't crashes at the last moment. So that will be something not very difficult because I have already integrated this image uploading capability. So I have to just play with the interface because everything OpenAI is ChatGPT can do everything. So it's not a problem with that. I just have to integrate that in our front end of Gradio app. So
no
can you guys
complaint at all. A quick question on the images. Image upload in the context of intelligent liquidity provision, or what
No,
will...
it can take any image, and just like you can upload images in the chat GPT, it can give you answer. And if this image has some kind of data which you can use to call a function, so that it can read that data too. So it can do all the functionalities which chat GPT can do. Plus, it can read data from the images, like it can read a graph of liquidity strategy or something like that. And based on that, it can call function also, so that it has combined the abilities of all that stuff. Can you guys see the screen of VS Code environment where everything is running?
Yeah, we can.
Okay, so here was the terminal where I was telling that what's happening. I can see everything. So all the responses which you saw on the Gradio interface, they are being processed here. So whenever what is going on in the environment, so here you can see that first of all, it called the chat GPT OpenAI model. Then it called a function, so everything which function is being called, what that function is returning. So here all the data is returned by that function. Then it post-process that data with another OpenAI function, OpenAI LLM call. Then after that LLM call, all the stuff which is going on the front end app, you can see that what is going. If you are trying to debug that, it's not calling the right function or it's not generating the right response. So here is the place where you can see everything happening. So after that, I will take you through the code, how to integrate your own tool. So it's very, very simple. This is the brain where everything happens. This Uniswap file, it contains all the functions. So all the function related to Uniswap, analysis, ILP related function, the framework which we discussed previously, the dual analytics function, and train DDPG model, train evaluate, and everything, every stuff. And you can just paste your own function in this file. You don't have to do anything else, just paste that function here. And after that, once your function is present in this Uniswap py file, you have to import that function here. So you just have to write the name of your function, whatever it is, here in this brain.py file. And after importing the function, you have to give the description of your tool here in this conversation function. So this is the first tool which we have integrated. So you have to provide the name of the function. What is the name of this function? Give a brief description that this function aims to assist user in getting the data of the Uniswap pools, and give a brief description of your function. Then you have to specify what are the different parameters of this function, like to get the data of top Uniswap pools, I need and the number of pools. So I have given this variable that this is the parameter of my function, and I have explained it briefly that it is the number of pools user wants to get data of, and gave it an example so that it understand what it means. There is another function, it has function name, a brief description, and just like you just have to integrate this block of code for your own function, and it can be integrated here. So you don't have to go and do anything else. Just give this brief description of your function, and it will be integrated in Token GPT. It can call it, it can give you the outputs and everything else. So here is the interesting part, which is you can do post processing on your function call. So let's say there is a function which gives you based on its simulation or something. It's a CAD simulation. So after CAD simulation, you get all the graphs, but you don't want to get graphs. You want something actionable inside. So here you can process that function using a custom query, like I can ask it that based on the response from that function call, I want you to provide me actionable insight that how I should go ahead with my token model or something like that. So it will not give you all the information which you don't really know, because simulation return a lot of data, a lot of plots which you don't want to see or don't want to go into. So you can just simplify it by asking it to just summarize all the data or give me the some actionable insight based on any criteria or anything. So you can post process the function calls here. So I haven't done much in this part because this is the thing which I discovered yesterday. So I kept it simple, just to ask it to generate a CSV file and give me a table of data. But even if I don't want to see the table of data on my interface, I can ask it to give me the post-process this data, give me some insights, give me only the pools which have the most trading volume or anything like that. So anything related to the post processing of your function call, that can be done here. And this third file of this token GPT, which has this Gradio interface, so it is very simple. You just define that how many boxes will be there on interface, what will be their size, and here I have this image uploading capability which you can see on front end that is implemented here. So even if I want to add the CSV file uploading, so I just have to write a very simple code of 5 to 10 lines to make it capable of reading CSV files or doc files or any other type of files. So that is very simple. That is very simple integration of tools and all the stuff related to token engineering with these LLMs. But I think the real innovation which we will be needing is to designing these tools. Like this is price impact analysis tool. We can have very complex tools integrated with them. Then we can use our skills of prompt engineering to make the responses from these function calls easier for the stakeholders to understand. Like if we want to integrate the DAO governance tools into this token GPT, so we will first of all develop those tools to get the data and how we want to post process data to present it to the participants of DAO, or how to analyze proposal, how to extract the relevant information from proposal to quantify the results of these proposals and everything like that. So that's where the real innovation is required to develop these functions which are relevant to this field, and they are useful for the people who are interacting with this token GPT. Okay, guys, so that's it from this session. We covered a lot in this, so this is also a private repository, but I will add all those interested into this repo. You can just send me your email if you want to try or test the different models and your own tools with it. So just develop on it and build this tool something useful which token engineers can use to help in their token engineering workflows.
Okay, thanks so much, Mohammed. Yeah, we have some questions in the chat. I don't know, Benui, would you like to switch on your mic and ask yourself?
Yeah, regarding the price analysis, I would like to know how did you do that? So I saw maybe a function in the Uniswap. So I wanted to know.
So here is the price impact analysis function. Can you guys see my screen?
Yes.
Yeah, okay. So this is one of the function which I actually implemented for one of our own project, the ALI token. So we just launched a certain new features of token sinks where tokens were being locked. So we were trying to analyze that how much these token sinks will affect the circulating supply of our token. and how the demand of our token will grow over the time based on these token logs and token utilities. So I performed this analysis here where I use some initial parameters of growth rate, decay, like number of byte transaction based on the real data of our token. So you can give these parameters specific to your token, and we can also get this data from the API. So you don't have to give this data of initial weekly transactions or circulating supply. It can directly get it from the CoinGecko API. And these are the parameters or assumptions that what will be the initial number of transactions, how many transactions are buy and how many sell transactions are happening, what will be the growth rate, what are the deltas of supply and demand and everything. And based on that, I extrapolated it for the for 52 weeks, which was the period of our interest. So I use these demand models and supply models to get this price impact analysis, and these were the results based on our parameters, but we can improve that. So there is one thing which I forgot earlier, that this is LLM data directory where all the plots which are being generated by token GPT and all the CSV files, like we can see this was the 5 days data which we got. These are the files from my earlier prompts. So this is the attendance day data. So all those files and CSV files and images, they are being stored here. So even if you get any data on the front end in form of a table, you can use it from this storage. I hope that answers your question, Benoit.
Yeah, that answers the question. Thank you.
Cool. And there's one more. Tiago raised the question, how prone is it to hallucinate?
So it's very, very efficient. It doesn't hallucinate. That is the primary purpose of implementing RAG, that it doesn't hallucinate, because then if anything presents in its knowledge base, so it is less prone to hallucination as compared to ChatGPT. So ChatGPT will a lot of the time, if you talk about the token engineering, it will give you the wrong information, even the wrong definitions. I have tried it a lot of time to just do simple kind of stuff like tell me that how to model the interest rate or anything, and even the basic mathematical formulas were not correct. So even if you are working with the Uniswap v3, so it will give you a lot of wrong responses. But this token GPT, because it has all this knowledge of white papers of Uniswap v3, Balancer, and all other DeFi platforms. Apart from that, the token engineering tools like CAD, Token Spy, it has documentation of all those tools in its knowledge base. So it is very, very less prone to hallucination.
Awesome. Thank you. Any other questions?
Okay, do we have any other question in chat?
So I guess Mohammed, you will drop notes in the Discord, so that how should the registration process work? People send you a message if they want to get access, and you add them to the GitHub, or how?
Yeah, they will send me an email, and I will add
Okay.
them to the GitHub, and
Okay.
they will go on this repository, and just with the couple of commands, they can set up this GPT with the front-end interface, and then after that, they can interact with that and everything. They can do everything.
So can we share your email address on the Discord then, so that, or please feel free to drop a note there yourself, so that everybody who's interested has the chance to get access.
Perfect. I will drop a note right after this.
Okay, anything else? Victor, you have a question.
Yes, I saw that you can also integrate Dune data, and since on a more general level, actually, like any kind of efforts that are collaborative, they obviously also include data that might not for malicious reasons, but maybe people make mistakes, or humans. Like I'm trying to learn a lot, and if there's some kind of data integrated or somehow reaching out to data and dealing with data that is not necessarily correct, I just wanted to ask, is there any kind of vetting system or anything that you can somehow implement to say, okay, it's not going to integrate this kind of data because that is just that cannot be right. Do you get where I'm coming from?
Actually, we don't have any kind of such system right now, because all the data, like if you are getting some data from the Etherscan or any other blockchain explorer, so that data is the most transparent data you can get from anywhere. So that data for that data we don't need to perform any security check. But for the centralized platforms which query this data and store into their databases like Dune or any other data querying platform, so for that, we should have some kind of vetting criteria, but right now we don't have any such thing. So if anything is being displayed on the Doom dashboard, so that will be accessible and it will process it. It's like it's authentic. But you are right, there should be some kind of vetting process. Once we will get to the DAO part, because their data is very sensitive and giving false data to the users and based on that making their decision, that will be something really concerning. So for that, we have to find some kind of vetting mechanism for the use cases like DAOs, management and all that stuff. So I will look into it, that how we can do this. Thank you.
All right, thank you. I'll try to make less mistakes on Dune then. I have a motivation for that. Thanks.
Okay, any other questions? And again, if you just go throughout next week, feel free to collect your question, bring them to the final session next Thursday. If related to Token GPT or any other machine learning AI topic in the context of token engineering, happy to have a good conversation and discussion in the final session.
Yeah, perfect. Do we have a couple of minutes? I just forgot to give an overview of last session.
5 minutes
so
left.
In last session, I have listed around 16 to 17 products which are being developed at the intersection of blockchain and AI technology. And there is a lot of potential for the token engineers to chip into these projects by designing better mechanism design. So BitTensor has recently they have a DAO proposal to improve their incentive mechanism, which wasn't there earlier. So that shows that the absence of token engineering experts on these projects, which they have to really they are not getting all that attention because there are not incentives for the decentralized participants. So there are a lot of research areas where token engineers can really contribute at intersection of these technologies. And we will discuss all those use cases which are being developed and what other use cases which can be developed and how token engineers will play their role in making AI decentralized and permissionless for the public. So there is a very critical role of token engineers in achieving this, and we will explore all those opportunities, and we will discuss that with you guys, that how you are interested in token engineering domain by contributing different kind of projects. So please join in our next session and let's have a discussion in this field about this field.
Awesome. Thumbs up. Thank you.
Thank you.
Good.
Thank
So
you, everyone.
I'd suggest we meet on Discord for further discussing. Again, send Mohammed an email to get access to the GitHub and play around with a Token GPT. And thank you for joining today. Thanks for the session, Mohammed. Thanks for all the questions. And see you again next week, Thursday, May 30th, same time, same Zoom place. Thank you.
Thank you, guys. Bye.
Bye.